Take it away, Mr.
I'm going to continue with my discussion that I want to have about quantitative error analysis. That's what we're going to call this. So it would not hurt to write this down, and it would not hurt to write this down probably in your lab book or in the notes. It doesn't matter. I don't really care. We're going to call this quantitative error analysis. All right? Quantitative error analysis. Now, due to the fact that we're dealing with numbers, I want you now to do your error analysis in a numerical or quantitative fashion. So, now the errors effect, right? And remember, that's that thing in the middle where I asked you to talk about the effect of the error must be a numerical analysis of what that's going to do to the dependent variable, of the dependent variable. All right? Now, how do we do this? We do this using two methods. All right? Number one, we have to use the equation that we're using in the calculation. So use the equation. All right? So we need to know what the equation is. And number two, we need to analyze the mathematical relation. All right? The mathematical relation. Let me give you an example of what I mean. All right? Let's say that the equation that we're using is y equals x over z. Let's say that that's the equation. And our dependent variable is y. We want to calculate y. In our lab today, we're going to calculate percentage magnesium. That's going to be the y. So let's say that we do a check of maybe the scale, and we find that the scale is reading too large, all right? And let's say that that scale number is x. So let's say that the error is x is too big. For some reason, the measurement x is too big. Well, what you have to ask yourself is, what effect does x being too big have on the answer y? What does that do to the number you calculate? If x is too big, therefore y, well, what will y be if the top number on this fraction is too big? What happens to the value of y when you calculate it if this number on the top is too big? What happens to it? Yep. It'll be also too big, because the top number, when it grows on a calculation, it makes the answer become bigger. And we can say then that y will be too big. All right? Why would we say something like that? Well, when we have the x on the top, we say that it's a direct relationship. We say that when one gets bigger, the other one gets bigger. That's a direct relationship. So, if x is too big, then y is too big due to the direct relation between y and x. And to finish your write-out, you could say, as can be seen by the equation that was used. You might even want to put the equation in to make a firm argument of what happens. What if we had an error that resulted in z is too big? What if z was too big? What if we did a measurement, we discovered, oh, z is too big. What will that do to the value of y? Yep. Yeah, because it's an indirect relationship. When your bottom number on a fraction gets bigger, the fraction total actually gets smaller. So if z is too big, therefore y will be too small due to the indirect relation between Z and Y. All right? What if Z was too small? What would happen to Y if Z was too small of a number?
Y would be too small.
Nope, Y would not be too small. What if Y was too small? Yep. Sorry, what if Z was too small?
I mean, Y would be bigger.
Y would be bigger because it's an indirect relationship. If the number's on the bottom, it's indirect. If it gets too small, the other one gets too big. Let's now use a real example in our experiment. So, in the experiment, we asked you for, can I erase this?
Yeah.
No? I'm going to erase the top part. In the experiment, we have to calculate the percentage magnesium. How do I calculate the percentage magnesium? We talked about it yesterday. What goes on the top? What goes on the bottom? It's a percent. It's a percent. Maggie, what do you got?
How heavy the magnesium is.
Mass of the magnesium.
And the total mass.
And the mass total. All right? Times 100. Excellent. So, what if some smoke escaped or some of the white powder got lost? If some white powder gets lost and falls out or falls off, which one of my numbers is going to be affected? So, error. Some smoke escaped. Or some of the powder, the white powder, was lost. Which one of the numbers is affected by that? Yep.
Total mass.
The total mass. Because the mg is weighed at the beginning. That didn't happen. We didn't lose it on the way to the scale the first time. But the total mass will be affected. The m total will be too small. Therefore, the percentage mg will be too big because of the inverse relationship between the total mass and the percentage magnesium. Indirect. Indirect and inverse really mean the same thing. Due to the direct relation. Blah, 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 dot, dot, dot. That means you've got to make it sound a little more flowery between the percentage magnesium and the total mass, as can be seen by the following equation. You give me the equation, I read it, it all looks beautiful, and you get nice full marks. How do you fix such a problem? Well, that's where you've got to be a little creative. How do we prevent some of that white smoke from leaving? Tell me what to do. That type of thing. All right? Now, notice I made the argument for percentage magnesium. Because the percentage magnesium and the percentage oxygen are linked to each other, if the percent magnesium is too, what did we say? Oh, I didn't even finish it, didn't I? What did we say? Too big. If the percentage magnesium is too big, what automatically happens to the percentage oxygen? It's too small. So, you can use that for one of your errors. All right? Now you got to find a second error. Whether you checked the scale or whether there's something else you were thinking about, that's up to you. Many of you asked, is this clean enough? What if it wasn't clean enough? What would that do? All right? That's where our error analysis is going to go from here. I want it to be, so that middle part where you say, this will affect the results. No, not good enough. That wasn't good enough back then either. You had to say how it was going to affect it. You're talking about numbers. You're telling me about relationships. You're making reference to equations. That's how we do an error analysis now that we have numbers. All right?
And this is due Monday.